RAG versus fine tuning. To understand this, we've spent a good amount of time talking about RAG. Let's let's spend a good amount of time talking about fine tuning. What is fine tuning? Machine learning models, as described earlier, are their systems, their architectures where they receive inputs, and then the inputs are passed through many layers of billions of parameters, little dials, and there's an output layer where the probabilistic outputs, the most probable outputs, are aggregated. Ultimately, you get one set of tokens as a output. And so these layers, 671 in the latest DeepSeek R1, the biggest one, 671 billion. When you fine tune a model, you change the there's two ways. One, you can change the weights, or two, you can actually add layers. So instead of 671 billion, there's 700 billion, and that's actually what happened between like GPT-3 and 4. Is just you add new layers. If you add new layers to a neural network, essentially, metaphorically, the brain gets bigger and there's more information, right? Okay, that's very hand wavy definition of fine tuning. Some ways of fine tuning are efficient. They use things called LoRa's, which are low ranking adaptations. We're not going to get into all of that. We may do an episode in the future on that, or we might do it with a guest. Suggest what you want in the comments. But when you fine tune, you fundamentally add new information is by way of layers, or change the weights of a model. With RAG, the model stays as is. This is very important. With RAG, the model, you never touch the model. The model is static. It's a set of weights. It doesn't change. And you introduce new context only through your prompt. With fine-tuning, the model itself changes. It becomes a new model. GPT-3 becomes GPT-3.5, becomes GPT-4. And new models have new capabilities because there's more parameters. For the case of getting real-time information, would RAG yield better results or fine-tuning yield better results? The answer is RAG would yield better results. And there's multiple reasons for this. Reason number one is that fine-tuning is just very expensive. Like very expensive. You require very expensive hardware. GPUs are not cheap, and you require many of them just to run the training workloads. The oldest, like attention is all you need paper that we cited earlier, I believe it took a few days and 8 GPUs running concurrently, right? And so it's not an easy thing. So it costs in terms of time, in terms of hardware, and in terms of compute, and in terms of electricity. It's just extremely resource intensive. And as part of the training process is performing what are called evals, or evaluating that the model actually works the way you want it to. That is also expensive because if you've not tuned some hyperparameters, these are parameters for the training process, like learning rate, epochs or epochs, and things like that. You need to tune them well. And if you've not tuned them well, then after a lot of training, you could have a model that yields really poor results, and you've wasted time, energy, compute. And so it's just laborious. And for what? Meanwhile, with RAG, you just get context, put in your prompt, it's done. And you can just adjust your prompt, which is way cheaper, even free, compared to creating a new model. So RAG wins. There's another reason why RAG wins, and that's because these are language models. Fundamentally, these are large or small language models. And in terms of what they generate and what they're trained on, is not really information and facts, it's language. And this is, you can see this with the hallucination problem, right? For example, Google's AI overview feature had people asking, hey, how many cigarettes should a pregnant woman smoke per day? And because it's good at language and not information, it said, pregnant women should smoke 3 to 5 cigarettes per day. This is like Google it. This is an actual thing that happened. Misinformation on google.com with the AI overview feature, because they're good at language, not logic, not information. Yeah. And so you can use RAG to help with logic and information by giving authoritative information in your prompt. But you can't fine tune information into the model. It is a language model. It transforms contextual input tokens to contextual output tokens. It's not logical input tokens to logical output tokens. It's contextually aware input tokens to output tokens. And so you start to see, okay, well, language models are great at language, not information. So here's the rule of thumb. For information, RAG is the best choice always. For correct and accurate data, real-time data and information, RAG is the method. Fine-tuning is not wrong. It's just If you're after real-time information and correct information, it's not the best, because ultimately a language model will always output language and not logic. So RAG is your super weapon there. Fine-tuning is good indeed. It's good for other things. For example, it's good for enhancing language capabilities. If you want a model to have better context, a better grasp, of nuance between terms, then you fine-tune. If you want to teach a model a new language, Klingon, Amharic, Azerbaijani, whatever, I'm just like an alphabetical order, Zulu, Xhosa. If you want to teach it these languages, right, then you fine tune, because it's language. It gets better at language. If you want to teach it a programming language, binary, assembly, Go, Rust, Java, Python, Scala, maybe you, like Keel, you have your own domain-specific language, or DSL. In that case, you want to fine-tune. No amount of RAG is going to get the right grammar of the language every single time, right? There will always be hallucinations because of the training data. Does this make sense? And so this is the answer for RAG versus fine-tuning. RAG is great for actual, authoritative, accurate, correct information and data and logical data, and fine-tuning is appropriate for language and so on. Fine-tuning, and the other benefit of fine-tuning while we're here, is also for saving money and compute, right? Because these language models are very large usually. Again, as I mentioned multiple times, DeepSeek R1, the biggest version of DeepSeek, is 671 billion parameters. Do you need all those parameters? For general use cases, yeah. If you have something like ChatGPT and you want it to be used by 100 million users and so on, you probably need a lot of parameters. But if you're a bank, a hospital, an individual, and you want a language model specific for your use case, like the podcast search of this podcast on tej.as, you probably don't need all those parameters. In fact, the more parameters you have, the more that can go wrong, the more that can be hallucinated, the more nonsense is in those parameters, yeah? And so you may need smaller models. You may need smaller, instead of LLMs or large language models, you may need SSMs or SSLMs, small specialized language models, that cater to your specific type of language. For example, the podcast search here is A/B tested with a smaller language model that doesn't really speak anything except HTML and a little bit of podcast language. It's a combination of RAG and fine-tuning that saves a bunch of money. Because the larger the model, the more expensive it is to run. The smaller the model, it's not. One of the best small models that you can use, it's open source, is Mistral 7B. There's only 7 billion parameters. That's 100 times smaller than DeepSeek R1, roughly, right? And if you can fine-tune Mistral 7B, it'll probably have a little bit more than 7B after it's fine-tuned, to your specific use case, then you have this awesome model that you can run for your specific case very cheaply, and even on your M1 MacBook Pro, right? And so fine-tuning is not without its benefits. It's very good. It's just you need to pick the right tool for the job. And again, I will say this again, for data and correct information, it's RAG, and real-time information, it's RAG. And for anything language-related or compute-related, the size of the parameters, fine-tuning is better. Finally, I'll stop this discussion with this. It's almost never one or the other. Never ever one or the other. A lot of people even do this with web stuff. Should I use React or JavaScript, which is such a strange argument because React is JavaScript, and it's usually you use both and you use them well. You use both with RAG and fine-tuning.